All right, let's dig into something that's, well, absolutely critical for anyone building in the cloud. Designing applications that don't just run, they survive. We're talking about how to build architectures in Azure that can handle the complete failure of a data center. It's a scenario you just have to plan for.
So, picture this. Your app is running perfectly. It's this beautiful multi-tier setup. Users are happy, everything's smooth. It's a work of art. But then, the unthinkable happens. The entire physical data center that it lives in just goes dark. I'm not talking about one server rebooting, I mean the whole building is offline. What happens then? That's exactly the problem we're going to solve today.
Without a resilient design, that single data center is a huge single point of failure. If it goes down, your application goes down with it. There's no warning, no slow decline, just boom, off. And that's not just some tech issue, right? That can be a full-blown business catastrophe.
The good news is we're not just sitting ducks here. Azure gives us this fantastic toolkit designed specifically for this. It's all about changing your mindset. You stop trying to prevent failure, because let's be real, that's impossible, and you start expecting it and managing it. So let's look at the key building blocks that make this all possible.
First up, availability zones. The easiest way to think of these is like separate, self-sufficient islands inside one big Azure region. Each one is its own data center with its own power, its own cooling, its own network, the whole deal. The whole point here is isolation. A fire or a power grid failure in one zone isn't supposed to affect the others. It's designed to contain the blast radius.
Okay, so now let's zoom out to the next level of protection, a region pair. This is where Azure pairs up two completely separate regions. They're usually hundreds of miles apart, but still in the same general geography to keep your data where it needs to be. This isn't for a single data center failure. This is your escape plan for when a natural disaster or a huge outage takes out an entire region. This table really nails the why behind all this. Zonal redundancy, that's for high availability. It's about keeping your app online if one local data center has a bad day. Regional redundancy, on the other hand, that's for disaster recovery. That's your break glass in case of emergency plan when a whole geographical area has a really, really bad day. Two different tools for two very different problems. So the real question is, how do we actually use all this stuff? Theory's great, but let's get our hands dirty. We're going to take a standard, kind of vulnerable multi-tier app and go through it, piece by piece, to upgrade it into something that can just shrug off a data center failure. And the plan is super straightforward. First, we secure the front door, the web tier where users come in. Then, we make the brains of the operation, the app tier, redundant. And finally, we protect the heart of it all, the data tier, so nothing ever gets lost. Let's kick it off with step 1. The very first thing we do is put in a smart traffic cop. A zone-redundant load balancer knows about the health of all of our availability zones. If it sees that zone 1 has gone dark, it just instantly stops sending traffic there. All the user requests automatically flow over to the healthy instances in zones 2 and 3. And the best part? The user has absolutely no idea anything even happened. Next up, the app logic itself. It's no good redirecting traffic if there's nothing there to handle it, right? So instead of running all our code in one zone, we spread it out. We deploy instances of our app, or our Kubernetes nodes, across all 3 availability zones. That way, if the computers in one zone go down, the others are already up and running, ready to pick up the slack without missing a beat. And now for the most important piece of the puzzle, the data. This is where things get really powerful. For a database like Azure SQL, we can turn on what's called synchronous replication. What that means is, a transaction doesn't count as complete until the data is physically written down in multiple zones. Now, there's a tiny bit of write latency, but what you get in return is huge. If your primary database in zone 1 fails, a replica in another zone is instantly promoted to be the new primary, with absolutely zero data loss. And this quote just says it all. What we've done here isn't just a technical tweak. It's a total shift in how we operate. You go from a reactive, all-hands-on-deck, 3 a.m. disaster to a managed incident. The system just heals itself, and your team gets to analyze what happened instead of scrambling to put out a fire. Okay, let's wrap all this up with a practical checklist. Think of this as something you can take with you and use on your very next cloud project. First off, you've got to know your application's critical parts. Then, when you pick your Azure services, make sure you're using the versions, the SKUs that are actually zone redundant. Don't put all your compute eggs in one basket. Spread them across at least 2 zones. For anything with data, you have to set up replication across zones. Use a smart load balancer at the front door. And finally, and I can't stress this enough, people always forget this, test it. You have to run failover drills to prove that this whole setup actually works when you need it to. By following these steps, you've built an incredibly powerful defense against a data center failure. You really have. But great architecture is all about continuously asking what's next. So the question I want to leave you with is this. Now that you're safe from a zone failure, what's the next assumption you've made? What's the next potential point of failure hiding in plain sight in your architecture?